Hello and welcome to this Reigate Maths video on looking at the roots and coefficients of quartic equations. We're just going to look at one example in this video, and it is quite long and needs more space than the booklet allows. So we're looking at this example here, and I'm going to do it on file paper. So what we've got is an equation ax to the fourth plus bx cubed plus cx plus d cx squared plus dx plus c equals 0. And we're told it's got roots a half, minus 1, and 2. And we've got to find the equation. Now, just before we start doing it, let's recap. We know that the sum of the roots, so alpha plus beta plus gamma plus delta, is going to be minus b over a. The sum of the roots in pairs, so each pair multiplied together, is going to be c over a. Taken in threes, alpha, beta, gamma is going to be minus d over a. And then taken as a 3, alpha, beta, gamma, delta is going to be e over a. So we've got quite a lot to work with here. So let's have a look at this, and I suggest you do this on a fresh piece of file paper because it just won't fit in the space in the booklet. So when you're told what the roots are a half, minus 1, and 2. So this is what the equation would look like factorized, and you could multiply that all out, but that would take a long time and very likely you'd make an error. So the method we're going to use here is to use the sums and products of the roots that we know. So the sum of the roots, that's what sigma alpha means, we know that's equal to minus b over a. So if we look at the roots, we're going to say that minus b over a is equal to a half, minus 1 plus 2, and that is equal to 1. So that's our first piece of information. Now, this is where we have to start concentrating. The roots taken in pairs is equal to c over a. So what we need to do now is we need to work out a half multiplied by minus a half. So that's the first pair. We're then going to do a half multiplied by minus 1. So I'm doing a half times this one, a half times minus 1, plus a half times 2. Then I'm going to do minus a half multiplied by minus 1 plus minus a half multiplied by 2. And then finally, minus 1 multiplied by 2. And we should have 6 pairs here, 1, 2, 3, 4, 5, 6. And when you work out what that's equal to, you might want to use a calculator for that, you get minus 9 over 4. So that is what c over a is equal to. Taking the roots in threes, alpha, beta, gamma, that is equal to minus d over a. So taking them in threes, you can think of missing one out each time. So that's going to be a half times minus a half times minus 1. So that one I missed out the 2. Then it's going to be a half multiplied by minus a half multiplied by 2. So I missed out the minus 1. Maybe use some brackets to make this nice and clear. Plus, we're going to miss out this one this time. So a half multiplied by minus 1 multiplied by 2. And then the final one will be minus a half multiplied by minus 1 multiplied by 2. And when you work all of that out, you will get minus 1/4. So work this out on your calculator. So we know that that is minus d over a. The last one to do is all 4 roots multiplied together. So that's going to be alpha, beta, gamma, delta. And that's going to be equal to e over a. So if we multiply them together, we've got a half multiplied by minus a half, multiplied by minus 1, multiplied by 2. And when we work that out, that comes out to be a half, and that's equal to e over a. So we've done quite a lot of work now, and it's a good idea at this point to summarize it. So we've got that minus b over a is equal to 1. That c over a is equal to minus 9 over 4. That minus d over a is equal to minus 1 over 4. And the e over a is equal to a half. Now, because these need to be integers, as the question asks for integer values, then we need to set a equal to 4. So if I set a equal to 4, then minus b is equal to 4 times 1, so b is equal to minus 4. C is going to be equal to minus 9. D is going to be equal to, now just watch your negatives here, A is equal to 4, so minus D is minus 1, so D is equal to 1. And then E, A is equal to 4, E is going to be equal to 2. So we have now found the smallest possible integer values of A, B, C, D, and E. Part B of this question asks you to find a different equation with roots 1 over alpha, 1 over beta, 1 over gamma, and 1 over delta. So the technique used for finding a new equation that has roots related to the first equation is to say, well, my new equation is going to be an equation in W. So we're going to have an equation that has a certain, it'll be a quartic equation, a times w to the 4th plus b times w cubed, and so on. And what we know is the link between w and x. So we want the roots w to be 1 over the roots of the previous equation, 1 over x. So wherever this is the link between the two equations, we rewrite this to be x equals 1 over w. And then we substitute this into our original equation that we were given in the question. So the original equation, which comes from this one here, would have been 4 times x to the 4. So that's 4 times 1 over w to the 4. Minus b is, sorry, plus b, so that's minus 4 times 1 over w cubed. Minus 9 times 1 over w squared plus 1 over w, wishing I'd written this on 2 lines, plus 2 equals 0. So that equation there will have roots 1 over x, which is what we're aiming for. So if we look at this equation here, we need to multiply all the way through by w to the 4th. So when we do that, we get 4 minus 4w minus 9w squared plus w cubed plus 2w to the 4 equals 0. And I would probably rewrite that with the powers descending. So this equation here, minus 9w squared minus 4w plus 4 equals 0, will have roots 1 over all of these values that we had in the first equation. So this technique of rearranging the equation with the new value of the roots will work for related roots when they're 1 over the original roots, and it will also work for linear combinations. And we'll look at an example of that in the next video.